Okay, welcome back. Lesson 25, solving equations containing decimals. Here's our little recipe for solving for x. I'll let you read through this, but basically if fractions are present, we're going to clear the fractions by multiplying by the LCD on both sides of the equation. If parentheses are present, we're going to use the distributive property. We're going to combine any like terms on each side of the equation, and then we will proceed to balance the equation as usual, as we've done in the past, and then hopefully check our answer at the end. So let's go to the next slide. Here I have a lovely equation containing decimals. I'm going to go the traditional route at first, but then I do want to talk about this option of getting rid of your decimals in a legal way, but I'm going to go traditional here, so distributive property. So that will be 0.01 times 5 is just 0.05. So we have 0.05, but a negative times a positive is negative, so it's negative 0.05a, right? 0.01 times 4 is just 0.04, but again, a negative times a positive is a negative, so we'll say minus 0.04 equals, now let me scoot, I was going to say let me scoot all this stuff down. Equals, okay, now here I have to distribute again, so 0.01 times a is just 0.01a, but that negative, by the way, this minus sign, you know, it always belongs to the number that's to the right of it, so I can essentially read that as negative 0.01, so I'm going to have this 0.04, I'm just going to keep it, 0.04, just drop it down and keep it, so then minus 0.01a, and then 0.01 times 4 is 0.04, but a negative times a positive is a negative, so negative 0.04, okay? When you arrive here, the recipe, if you will, says to combine like terms, so 0.04 and negative 0.04, well boy, they just cancel out, right? So now we have negative 0.05, always constantly practicing recording my thoughts, and here I have negative 0.01a. Now, I always told you get your letters to the left and your numbers to the right, and I'll just stick with that. So, you know, here's a letter, here's a letter. I'd like to get all my sort of A guys on the left and my plain old number to the right. So I'm going to add 0.01a to the other side of the balance, if you will. Why? Because negative 0.01a and positive 0.01a cancel. So you're left with nothing on that side of the scale. And the negative 0.04, I'll just keep that temporarily, keep that hanging out. And then here, let me erase that, sorry, that stroke there that happened. Pen's being fussy today. So that was 0.05a. Okay, so negative 0.05a and 0.01a, I like to think of it, if I have a loss of 5 cents and a gain of 1 cent, I'd still be in debt, so negative 0.04a. And then the final frontier, letters on the left, numbers on the right, right? So I'd like to take the negative 0.04 and chuck it across the equal sign, but I can't just chuck it. I have to do the right procedure. So if it's negative, opposite is adding. So we'll add 0.04. That's called the add-up property of equality. So we'll add 0.04 to the other side of the balance. Negative 0.04 and positive 0.04 cancel, which we want to happen. So here we have 0.04. On this side of the scale, we have negative 0.04a. And we know we use the division property of equality to solve for a. So we divide by the very coefficient that's in front of it. So divide both sides by negative 0.04. And then, voila, we know that anything divided by itself is 1. So 0.04 divided by 0.04 is 1. The fact that you've got a positive divided by a negative just makes it negative. So voila, negative 1. Now I had the answer pasted in there, negative 1. Now, in reality, I should take negative 1 and, you know, throw it back into the original and check it out, see if it balances. For time's sake, I'm not going to do that. I'm going to let you do that on your own time. But a equals negative 1. Now I do want to talk, though, side note, I want to talk about if you don't want to deal with the distribution of decimals, what an alternative option is. So I'll hit pause as I set that up. So what I've done is I've repeated the equation here, and I want to talk about an alternative option. So just right here, optional. Notice that there's 1, 2, 1, 2, 1, 2. There's two decimals. There's two digits behind the decimal. Now, what I can do is I can legally slide this decimal 2, slide this decimal 2, slide this decimal 2, and create whole numbers. Now, why is that legal? Well, because here's the equal sign. So it's really like multiplying both sides of the equation by 100. It's really what you're doing. Multiplying by 100 is like moving the decimal over 2, right? Now remember that you don't treat, so note to self, not in here. Don't do that to things that are inside the parentheses, because they'll be affected by the distributive property later. So note to self, same thing in here. Don't mess with what's in there. So not in here. Okay, so you'll see, long story short, I'm going to do a rewrite and clear the decimals. So if I slide 2 to the right, I'm going to have -1 times 5a plus 4. And this is just a nice way to get rid of your decimals in a legal way. Slide 2 to the right, I'm just going to have 4. Slide 2 to the right, I'll have -1, and then I'll have a plus 4. And notice that anything that was inside the parentheses stays. You know, it's not affected by anything. Okay? Now what I'm getting at is if I solve this, I'm going to get the very same answer that I got earlier, but in an easier manner because I don't have to deal with the decimals. Okay? Distribute -1. So I'll have -5a minus 4 equals, distribute the -1, 4 minus a minus 4. And voila, the 4's cancel. Now I've got -a on this side of the game, and I've got -5a minus 4 on that side of the game. Again, we want your numbers on the right and your letters on the left, so we'll add 4. Okay, so now I have -5a equals -a plus 4. That's an a. I want to get my letters on the left, so I'm going to add a. Now on this side of the scale I have just 4. -5a plus a makes -4a. And then divide both sides by the coefficient. And voila! 4 divided by -4 is -1. So what I'm getting at is no matter what, I'm still going to arrive at the right answer. Whether I take this path of getting rid of the fractions, getting rid of the decimals in a legal way. So note to self, clear decimals. So whether I take this path of clearing decimals or whether I deal with the decimals as I did earlier, I'm still going to arrive at -1. Okay, now let's go to the next slide. Now that I told you the bit about getting rid of decimals, I'm hoping that's appealing for you. So 1 behind the decimal, 2 behind the decimal, 2 behind the decimal, 1 behind the decimal. You have to use the max. So max equals 2 digits behind the decimal. So I'm going to slide 2. So if I slide 2 on that, I'm going to have 250x. Slide 2 on that, I'm going to have 325. Slide 2 on that, I'm going to have 601. And slide 2 on that, I'm going to have 340. And voila, it's pretty much cooked. Now we've gotten rid of the decimals in a legal manner. Let me fix my 2 here. That should have been the number 2. It's kind of an awkward looking 2. Letters on the left. So I'm going to subtract 601 to the other side. And numbers on the right, so I'm going to subtract 325 to the other side, so that balancing of the equation. So on this side of the scale, we get -665, so -665. And whatever 250 minus 601 is, so that's what, 351, but negative. So you can kind of maybe do the mental math there. And when you arrive there, you can just simply divide both sides by negative 351. Oh, sorry. Pen's getting fussy again. Now, a lot of people say, hey, but a negative divided by a negative is a positive. That's true. And also the fact that you have this improper fraction. I'm more concerned, you know, with the mechanics of it all. So a lot of people ask me, you know, do I have to turn this into a decimal? Certainly not. Do I have to reduce it? Well, that's something to explore. It is simplified, but like I said, when you don't have to change that into a mixed number, you would have to if it was a reducible, but check this out. You know, you can key in 665 divided by 351 and you'll get a decimal. But you'll see that if I hit frac, it doesn't, the calculator would normally reduce it for me, but it doesn't reduce. But you can use your divisibility tests. I mean, can you find a number that divides evenly into both of those? So you'll quickly see that it's simplified. I did want to talk also, I do this in my upper level classes, about a lovely website called Wolfram Alpha. So hold that thought. So when it's midnight and you have no one to help you, notice I just typed this equation into Wolfram Alpha. You can get an app on your phone as well. Hit enter. And look, it spits out the answer for you. And if you have the app, you can hit step-by-step solution. But like I said, 665 over 351, that's just a crutch, right? I just wanted a little crutch, you know, the computer to tell me, yes, you did it right. So I only lean on Wolfram Alpha after I've done the problem myself. Again, here with this one, I have 1.25x equals negative 0.375. And like I said, if I want to legally dodge the decimals, 2 behind the decimal, 3 behind the decimal, I'm going to have to slide 3 right. So you'd look for the max amount, slide the decimal 3 to the right. Okay. So then I'll have 1250x equals negative 375. And like I said, the final stage is just divide by the coefficient. And like I said, when you arrive here, this makes me happy. It's just that we'd like to see that reduced. And for time's sake, just for time's sake, you know, I could divide by 25 or 5 until I got it reduced. I'm going to kind of cheat. So 375 divided by 1250. I hit enter, and then obviously that's 0.3, but then I hit math frac 3/10. So that's going to reduce down, and then it's negative, so it's going to reduce down to negative 3/10. And you can give me decimal or fraction form of your final answer. Either one is fine. Okay, and then I think we have one more. Yes, one more. So I move to the next slide. Now what you're noticing here is that I've kind of got a mixed bag, right? I've got a fraction, a decimal, whole number, an integer. Yeah, I've got all kinds of things. But the recipe, if you look back at that original recipe, let me go back. See, it says if fractions are present, multiply by the LCD. Aha. All right, well, that means I've got to multiply this whole thing by the least common denominator to clear that fraction. So, which is clearly 3. So the LCD is 3. So the trick is, though, you know, you multiply it to the left side of the equation to clear that fraction, but you multiply it to the right side of the equation as well. So what I'm getting at is you take 3 times 2/3, and then you've got your x minus 0.05, just keep that as is, equals, and then 3 times that quantity. I'm just going to write it like 3 times that quantity, x plus 1. Distribute on that side of the game, on that side of the playing field, so 3x plus 3. And on this side of the playing field, that was the whole point, was to clear that fraction. So now I'm going to have 2, and then distribute that 2 through the parentheses. Bing, bing. Okay? And then I arrive at 2x minus, and maybe by now you're getting good at doing that in your head. 2 times 0.05 is 0.1. And of course it's negative, so negative 0.1. And then equals 3x plus 3. And I like to do letters on the left, numbers on the right, so I'm going to move 3x over when I balance my equation. So 2x minus 3x is negative 1x. And I like to move 0.1 to the other side, so I'm going to add 0.1 to the other side. And if you like, you can say 0.1. And then when you're adding, well, 3 plus 0.1 is just 3.1. And then in the tail end of the problem, you're dividing by negative 1. And that's just going to change the sign. So we're going to arrive at negative 3.1 as your final answer. And like I said, after I get my final answer, I like to go to Wolfram Alpha and type in the original and have it solve it. Okay, so let's hit pause as we do that. So you'll see what I've done. As I went to Wolfram Alpha, literally typed in, solve this equation, and it spits out the answer negative 31 over 10. I'll have it give me approximate form, negative 3 point, decimal form basically there, negative 3.1. And voila, we've confirmed our negative 3.1. So like I said, Wolfram Alpha is just a nice little crutch to make you feel better about your solution. Okay. And especially if you don't have the time to throw your result back into the original equation and check it out. And I believe, yep, that was our last one for these guided notes. Okay, good luck out there.